Okay, now let's talk about the mesh current analysis method. Okay. Uh, Earlier we do the nodal analysis method, right? Node voltage, right? Node voltage analysis. We solve for node voltage, right? VK, any VK, and we use KCL to form the equation, right? We use KCL to form the equation. And for mesh current analysis, we find out IK, right? I of the mesh, I mesh. Okay, and we use KVL to form the equation. So to do the mesh current analysis method, first we define each mesh current consistently, right? Here. And usually we use the direction of clockwise direction as the positive. The current flow I1 is positive. I2 in this direction is positive, right? And how much the current flow through R2? The current flow in R2 would be I1 in this direction minus I2 in this direction, right? The current I of R2 will be I1 minus I2 like this. This is the current flow from at R2. This is important for doing mesh analysis. Okay. So here, unknown mesh current will be always defined in the clockwise direction. So this is unknown. We don't know how much IA, we don't know how much I2, we don't know. Because it's a voltage source. If you have the voltage source, it's better to do the analysis by mesh analysis, right? Because we know the voltage, but we don't know the current. Okay. And in case you have the current source in the circuit, you can define the direction in associate with the current source. Okay. And in the circuit with N mesh and M current source, the equation will be N minus M because we know M value already. We know M value of the current because if we have the current source in that case. And we apply KVL to each mesh containing unknown mesh current for unknown. In this case, we don't know I1, we don't know I2. So we will have two equations, for example. In this case, plus this the current flow to R1 would be plus minus here, right? And here is plus minus. If we apply KCL to mesh 1, KVL, right? Will be VS, right? VS, this is positive, this is negative, right? Flowing out from negative, minus R1, I1, right? And what is the current flow here? The current flow here will be I1 minus I2, right? And then minus R2 into I1 minus I2 because it's the net current flow, right? This is net current of R2, right? Equal to 0 by KVL. And for mesh 2, it would be plus, minus, plus, minus, plus, minus, like this, right? Because this is the current flow here. So minus, start from R3, minus R3, I2, minus R4, I2, and how about the current flow R2 in the upper direction? This will be minus R2 into I2 in this case, in this direction, R2 minus I1, I2 minus I1, right? This will be I2 minus I1, just like that. Just be careful for the positive and negative side with the direction. Similar for nodal voltage analysis, right? Node and mesh analysis. you just do following the pattern, right? You don't need to create uh, any new theory or any new equation. The equation is fixed, right? Each circuit will have the exact equation with the number of unknown, right? So in this case, we know Vs, right? We know Vs, we know Vs, we know R1, we know R2, we know R3, R4, R2. Then these two equations we solve for I1 and I2. Okay, after we know I2, we will know the voltage here. We know the voltage here, the voltage here also, right? So we know the current flow to the path. We can get the current flow pass R2 by this value, right? This is the current flow in this branch, right? Is I1 minus I2. You get this current also. So after we get I1 and I2, you get all branch current flow also. Okay. It's not very difficult, right? Just follow the instruction, right? For node and mesh analysis. Okay, let's see this circuit. Okay, this circuit we will have two mesh, right? Mesh 1 and mesh 2, 1 and 2, right? And we just apply KVL, right? We do KVL this loop and KVL this loop. So we get the equation to solve, right? For two current, right? So this is current I1 and this is current I2 here. Okay. First apply the KVL with this loop. So what we know is V1, right? We know V1. Oh, sorry. We know V1, V2, V3, right? We know no value and all R. We know all R value. Okay. So apply KVL here. It's V1, right? V1 and minus. So this is plus minus flow out from minus I1 into V1, right? I1 so I1 into R1, right? R1 to I1, R1 multiply with R1. Okay, minus V2, right? Because this is the current flow out from the negative uh, polarity, right? And minus I1 minus I2, right? Here, I1 minus I2 time R2, right? Time R2. This is third equation. And then similarly for the second mesh, we can get a KVL equation as well. This will be R2, right? R2. I1 minus I2. If you uh, uh, assume the current flow in this direction, it will be plus minus here, right? Sorry. Yes, sure. I1 minus I2 in the positive side here. Or sometime I will use this form like I2 because I use this as a priority with this direction. So I2 will minus I1 and the polarity of R2 will be plus and minus like this. It will be R2 plus and minus. It will be minus 4, right? Into I2 minus I1, right? So this value and this value are the same, right? You can use this method as well. It depends on you. Maybe you just select uh, one instruction or one pattern, right? But be careful if you use uh, the which method. You need to just make a consistency. Okay, otherwise you will get uh, the wrong sign of the current, and your answer will be wrong, right? Your answer will be wrong, right? So just be careful about the sign. Select one consistency method. Okay, and do not confuse when you do the exercise, right? This the exercise will help you to make a consistency, right? And then what happened in this direction? It would be plus V2, right? Plus V2 plus minus R3 into I2, right? And then minus V3 here and minus R3 into I2 here, right? Plus minus, right? So that's why usually I myself prefer to use this form rather than this form, right? This is equal, but I just still choose this direction of the mesh to form this current, right? Okay, you understand this? Okay, and then next step, we just substitute the known value, right? We know v1 is 10, I1 is 5, for example. So we just still known value. The unknown will be only I1 and I2, right? Then this equation will get these two equation and we solve for I1 and I2, right? Then after we solve these two equation, we will get I1 and I2. Then I1 is 0.5, right? 0.5 and I2 is 0.6. It means that current flow here is 0.65 and current flow in this mesh is 0.5. So what is the current flow across R3, right? Across R3, it would be I2 minus I1, right? The current flow in the upper direction, I2 minus I1, this will be 0.15, okay? So I across R2 would be I2 minus I1, that is in the upper direction, right here. It will be 0.15 here. So we know all current flow, right? And this is 0.5, and it is 0.65, and then this current is 0.15, right? The K satisfy the KCL at this node also. Okay. Okay, come to another example. So write the main current equation for this circuit, right? Okay. The known quantity is V1, V2, R1, R2, right? But the equation ask us just to write the equation. You don't need to solve the equation, right? Just make the equation, okay? And so we have three mesh for this circuit: I1, I2, I3, and then what is the KVL for mesh 1? This one would be V1, right? If I write down the equation, I will do like this. V1 and the current flow I1 in I1 direction, it would be plus minus here, and it's plus minus here. So first equation would be V1 minus R1, right? Minus R1 with I1 minus I3, right? I1 minus I3, and then minus R2 with I1 minus I2, I1 minus I2 equal to 0. This is my first equation. And then for the second mesh equation, I will do this direction, right? I2 direction will be plus and minus, is plus and minus, like this. V2 plus minus minus, like this. This will be V2 minus, right? Minus R2 in this direction, I2 minus I1. I2 minus I1 in this direction I2 minus I3, right? Yes, R3 minus R3, I2 minus I3 equal to 0. Okay. Then for the last mesh here, for this mesh I3, I will use the direction of I3 as positive, yeah, plus minus, right? And this is plus minus, and this is plus minus, right? Because current flow from positive to negative, right? Yeah. So in this case, with this two, this will be minus R1 into I3 minus I1, I3 minus I1, and minus R4 with I3, minus R4 with I3, and minus R3 into I3 minus, because this form, right? I3 minus I2 minus I2, right? So I will get three equation with three unknown that are I1, I2, and I3, right? These three equation with three unknown, and then I just solve for these three unknown, right? So I recommend you to try substitute the known value and rearrange this equation. You will get these three equation. Okay, just check it is the same or not. This the equation I wrote down here, and these three equation are the same. Okay, so then if you get these three equation, the next step is to solve, right? To solve for I1, I2, and I3. Yeah, it's not difficult, right? Because the equation is linear equation, right? This is a linear form equation. You can use the metric method, or you can just reduce the unknown variable one by one, right? Try to reduce the unknown variable. Okay. So I believe you can do this. Uh, uh, you can solve this equation set, right? So an equation, this is very important to get the concept idea, right? To catch up the concept, and you with this concept you will be able to do for every circuit. Okay, with this concept you will be able to solve every circuit, right? But it depends on how many equation will come out, right? If you do it correctly, the number of equation and the number of unknown must be the same. Okay, right? Just apply KVL, just apply KCL for nodal analysis. Okay. Okay. Next, let's see the mesh analysis with current source. In case we have current source, what happened? Because if we have the current source, we will not know the voltage across the current source. We don't know the voltage across the current source, but we know the current. We know this current equal to Is, right? Here, equal to Is, we know this current. And in this case, with current source, we need to define the direction of the mesh in accordance to the current source here, right? When a current source is present, okay, unknown mesh current are always defined in the direction of current source. You can see that uh, the common mesh we use clockwise direction, but with current source we need to define the current of that mesh in the same direction with current source here. Same direction with current source here. This is the common practice, right? So after that, you just apply KVL to each mesh and then solve for the unknown variable. Okay, for example, with this circuit, we have two mesh, but we know this current, or we know this current, and the current is IS in this direction, and this current is I1. So we don't know I1, we just solve for I1 here, right? So if we apply KVL to mesh 1 to mesh 1, it will be plus minus here and plus minus here, right? With this direction, it will be plus Vs here, Vs minus R1 into I1, and the current flow through R2 will be I1 plus IS, right? Because IS also this direction, I1 is also this direction, the same direction, R2. So plus minus here and minus R2 with I1 plus IS, I1 plus is equal to 0. So in this case, we have one equation with one unknown, okay, which is I1, right? We don't know I1, but we know Vs, R1, R2, and Is, so we can solve for I1 directly from this KVL, okay. So if you have the mesh, the current source in the circuit, if you use the mesh analysis, so that current will be known, right? It's a known current, but we don't know the voltage across. So if you apply KVL to this mesh, you will have a trouble, right? Because we don't know how much voltage here. We don't know. Okay, if you want to know the voltage across IS, after you need to solve for I1 first, and then you get this voltage. If you get this voltage, you will get the current here, right? IS with R3 will be equal to, for example, V2 plus IS R3, like this. You have to solve the voltage across the current source later, after you get all variable, you get unknown variable. The important variable is the mesh current first. Okay, let's see some example with mesh current. We have three mesh here, but in this case we have current source. If we have current source, we don't know the voltage across the source, right? This is the problem. So we will establish the KVL for mesh 2 and mesh 3 only here. Okay, so in this case, mesh 2 KVL would be here, right? I2, I1, we don't know I1. Okay, we don't know I1, but we know I here. I1, I2 plus minus here, plus minus here, right? The best way is to give the polarity across the resistance first, right? To make us not confused when we form the equation, right? So I make a polarity of the resistance first here. Then minus, and then plus, right? So it would be minus R2, I2 minus I1, right? I2 minus I1 minus R3, I2 minus I3, I2 minus I3, and then plus V. plus V equal to 0. This is this mesh. And then this mesh. What about this mesh? Mesh 3. I will write down plus minus plus minus, right? Because current flow this direction is plus minus like this. And then start with R1, right? Plus R1 plus minus R1, sorry, minus R1 minus R1 with I3 minus I1 I3 minus I1, right? And minus R4 minus R4 and I3, right? And minus R3 with I3 minus I2, right? I3 minus I2 equal to 0. Okay, so we have this equation is similar to this equation, right? And we have this equation is this equation here. Okay, then I1, we know I1 because I1 will equal to I, right? Here, this is I1 and this is I, right? And this is I1. I1 is I is 0.5 m. We just substitute I1, right? So we know the variable R2, I1, R3, V, right? And we don't know I2 and I3. Here we know R1, we know I1. I1 is I, right? And R4, R3, right? So we have two equations, two unknown, right? After substitute the known variable, we will get these two equations, and we solve for I2 and I3, right? You know the current in this mesh and in this mesh, right? After that, we can get the current flow to each branch, right? For example, if we would like to know how much the current flow in this branch, it will be I3, right? In R1 branch, it will be I3 minus I1, right? In this case, right? And I1 will be I, right? This will be I3 minus I, for example. So after we get I3 and I2, we get all branch current. After we get mesh current, so the mesh current will make us know branch current, right? Here we can get branch current from node current here. Again, please check this by yourself. Okay, if you have nothing to do, just try to remind again with the example, right? And try to check how to solve the equation by yourself. I think this is a very good practice, right? To make you more to get some more skill, right? Or problem solving skill, and this will help you in the examination activity, right? Okay, again, the last example of mesh analysis. Okay, I think I cannot finish this this slide. Okay, maybe I have to leave principle of superposition for next time. Okay, let's see our last problem, our last example for today, and I will give you a homework. Okay, example 3.11, find the unknown value Vx, right? Okay, not just solve for the current, the mesh current, right? I told you that after we get the mesh current, in fact, we use this to solve for other variable, right? Unknown variable. We can use the mesh current to solve for uh, so for answer, the remaining variable, right? The remaining variable. Okay. Okay, here 5Vx, right? Okay, we have to find out the voltage across the current source, usually unknown value, right? Vx, 5Vx. Okay. In fact, we can use any method. We can use nodal analysis or we can use mesh analysis. Okay, in this case, we use mesh analysis. And we have two mesh, I1 and I2. And I2 will be IS, right? I2 and IS are equal here. I2 equal to IS. And I will form the, and we have current source. Mesh 2 need to form in the same direction with current source, right? We need to form this direction, right? Which is clockwise direction. And the common mesh without current source, we form it in clockwise direction here. Okay. So I will form KCL of mode 1. So it's positive, negative here. Positive, negative here, right? So it's Vs like this. Okay, Vs this will be Vs minus, right? Minus R1 I1, and what is this? Minus, right? Minus R3 and I1 I1 uh, I1 minus I2, I1 minus I2 is IS, right? We can say here I2, or I just can write out IS here. It's also fine, equal to 0 here. So substitute the value. We know this will be Vs. What is Vs? Vs will be 10, right? 10 minus I1 is 5, or I1 minus R3 is 4, I1, I2 is 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 2 ampere, right? Equal to 0. Here we can solve for I1 very easy. So then we get I1 is 2 amp here, 2 ampere in this case. Okay. So in order to get Vx, oh not here, Vx, how to get Vx? Okay. Now we know that I1 is 2 ampere. 2 ampere. So the current flow here is 2 ampere, right? Current flow here is 2 ampere. And the current flow here is 2 minus how much? 2. 2 ampere, and this is also 2 ampere. So no current flow to R3 in fact here, right? Because it's 2 minus 2 ampere, right? 2 ampere minus 2 ampere. I is 2, is correct or not? Yes, 2 here, 2 ampere. Okay. So what is the voltage here? The voltage here would be Vs plus I into R1, right? Plus I1 into R1. Vs is 10. And this is R1 is 5 ohm. 5 ohm. And the current flow is 2 ampere. So 10 plus 10 is will be, oh no, this is 10. This is 10, right? And this is 2, and this is also 0 voltage, right? It's 0 voltage because this is 10 minus 10 is 0 volt, and there no current flow, and this is neutral current, no current flow in this direction, right? and it's just flow like this. And 2 ampere flow here, it will flow past to here, right? This is 2 ampere also, 2 ampere flow. And what is the voltage here? The voltage here is the voltage across this value, right? So it will be R2 is 2 ohm. This is 2 ohm, and this is plus minus. The voltage here will be minus 2 by 2 is minus 4 volt. So the voltage Vx is minus 4 in this case. So Vx is minus 4 volt here by 2. 4 and 4. Okay, this is plus 4 minus 4. Okay, this KCL is satisfied. Okay. Any question so far? Okay, and then your next homework. I don't know why this is homework number 3, because I just assigned you one homework, right? Last time, maybe this is maybe homework number 2. Better. Yes, this is a second homework. Your second homework, and 1, 2, 3, 4, 5 question. So how many days you need for this homework? So to solve the nodal analysis, and mesh analysis, just for your practice. 1 week, okay? Next Monday is okay for you?
โอเคค่ะ
Okay, next Monday. I think next Monday we will make a deadline, right? Next Monday. Very hard work this term. How many course you take this in this term, right?
only just only 4 teacher
4 course, not so hard, right? Monday,
very hard teacher
very hard. Monday is okay, 27, right? 27, 27. Okay, this is the deadline, right? And we have this is your second homework. Okay, I will stop record here.